Let's start chapter 7. We're going to take a look at 7.1, inverse variation. Now let's just go ahead and jump right into the vocabulary of what is inverse variation. It's a relationship between two variables where one increases and the other decreases. We'll eventually get to this constant variation coming right up. Well, what does all that mean? Okay, first off, let me give you a table to start off with right here. I've got x and y. And let's go ahead for values of x. I've got 3. I'm going to go ahead and put 6, 12. And for y, we have 20, 10, and 5. So the relationship one increases, the other decreases. Let's look right here. For x, I've got the values increasing because I'm going from 3, 6 to 12. With y, it's also decreasing from 25 or 20, 10, and 5. It's going up and it's going down the same amount each time. So think about this. If we take a look at our core concept, inverse variation, two variables, x and y, show inverse variation when their relationship is as follows. Y is equal to a over x. And a happens to be the constant. That is the constant of variation, and y is said to vary inversely with x. Well, what does all this mumbo jumbo mean? Think about this. If I take x and y, and I plug y into the equation right here, and let's say I go ahead and put 20 is equal to a over x, which is 3. What do we get for a? If I multiply both sides by 3, I end up with 60. Okay, so keep that in mind. Let's take a look at the second equation, or 6 and 10. If I go ahead and put 10 right here is equal to a over 6, I multiply both sides by 6 to get a by itself. Guess what? I end up with 60 again. Well, let's try one more time. Let's go ahead. I put 5 is equal to a over 12. And I go ahead and multiply both sides by 12. Guess what I get for a? 60. So the pattern here is this. A is constant. It's 60 in each and every one of these. One value goes up, which happens to be x, and the values of y go down, and then so there is our inverse variation. So to take it one step further, let's go right here and take a look at this term of direct variation. Now, you don't really see direct variation here on this page. Well, that's why I have it typed out for you right here. So direct variation is when I take y and I set that equal to a times x. Okay, so it's a little different right here. Y is equal to ax. A is constant. When one variable changes, the other one changes in proportion, and that's when we have a direct variation. Y is equal to a over x, inverse variation. So right here, what you'll notice is that in inverse variation, the products x and y are constant. In direct variation, the ratios y over x are constant. All right. So let's go ahead and put it all together. Let's take a look at number 1. So let's tell whether x and y show direct variation, inverse variation, or neither. All right, when I take a look at these equations, the first thing that pops out to me is the fact that, they don't have y by itself. And so that's one thing that you're going to need to start off with is to solve for y. Okay? That's step 1. If you don't solve for y and you're trying to do all this, you're in for bad news. All right, so let's go ahead right here. I'll go ahead and try to get y by itself. We're going to have to divide both sides by 3x. And so y is equal to 1 over 3x. 1 is constant. We have y on the other side of the equation. We've got x underneath in our denominator. So what that tells me right here, this looks like it is inverse. All right, that is the the relationship that is shown. So let's take a look next up at number 2. I already have y by itself, so we got 5 over x is equal to y. 5 is the constant, x is in the denominator, everything looks good. We have ourselves inverse as well in number 2. I'm just going to go through these to try to give you as many examples as possible. In number 3, y is by itself, but we have x plus 11. And there's no way I'm going to get x over 11 right here. So this right here, I don't recall having direct variation or inverse variation looking like number 3. So this will be neither. Let's go next up to number 4. We get y by itself. Let's go ahead and subtract x to both sides because that's all we can do right here, right? Subtract x to both sides, negative x minus 2. That right there doesn't look like direct or nor inverse variation. So we have once again right here, neither. Moving along, let's just truck through right here. On number 5, I've got 5 is equal to 4 over 5x. Now, think about this. If I were to multiply the 4/5 and x, I could actually rewrite it as 4x over 5. They're the exact same thing. Okay, so if you look at it that way, hopefully you realize, all right, that doesn't look like inverse. Okay, doesn't look like that at all. This looks like right here, direct variation. Because actually, instead of multiplying together, we could actually say this 4/5 happens to be a. But I put it together just to kind of show you, well, it doesn't look like it's inverse, right? Because x is not in the denominator, all right? And therefore, we have ourselves direct variation on number 5. Let's take a look at number 6. Let's see what we have here. We get y by itself. We'll try to put things together. I'll go ahead and subtract x to both sides. Divide everything by 8 or negative 8, and I got ourselves x over 8 plus 1 over 8 or minus 1 over 8. That does not look like any type of variation right here. And this, once again, is neither. Let's take a look at number 7. Okay, we have ourselves x over 7 is equal to y. This is looking similar to that of number 5. Look how I put number 5 together, right? I put 4x over 5. This one right here is x over 7. This right here, once again, is direct variation. Now, if I said, what's the a term, what would it be? A is equal to 1/7. All right? So I'm kind of showing you with number 5, putting it together, how number 7 happens to have the same relationship. Next up, we look at number 8. We got ourselves, we get y by itself. Y is equal to 0 over 6x. It looks very close right here to being possibly direct variation. But we have 0 in our numerator. It won't matter what's in our denominator because we're going to end up with 0. Right? So that's going to be a problem unless x happens to be equal to 0. So remember, when you take a look at the notes, if we go right here, some key things that appear is that, hey, in direct variation, a cannot equal 0. We can go ahead and say the same thing for direct variation, because if a equals 0, then you're going to always end up with 0 as well. So right here for number 8, we end up with neither. And then finally, let's take a look at number 9. We'll go ahead and multiply both sides by 9x to get y by itself. And I've got 9x times 1 is 9x. That right there looks pretty direct to me. All right, so there we have number 9. So then Now we're going to take a look at a table and figure out whether we have x and y showing direct or inverse variation. And so remember, one value needs to go up, the other variable needs to go down. Okay? And it needs to be consistent each and every time. We got to see if the products are consistent or if the ratios are consistent. So let's see what we could do right here. If I take, remember, I take 4 and 2, which is x and y, and we want to see, does that equal a? Remember in the very first thing, when we talked about inverse variation, I gave the table. And I said, hey, check out what's happening each and every time. All those numbers end up equaling 60. Well, let's see if I go ahead and multiply both of these together right here, if we have ourselves what type of variation we have. We got ourselves 2 times 4, right? If I take 2 times 4, that equals 8. And I got 4 times 16, that right there equals 64. 6 times 36, that equals, looks like some big number. What is that right there? 36 times 6. I've got 216. And so I'll just go ahead and there, because if I take a look at that, I don't see the same number appearing each and every time. Okay, so then how about this? What if I take right here, put y over x, right? If I take 4 divided by 2, that equals 2. How about 16 divided by 4? That equals 4. 36 divided by 6, that equals 6. So I'm looking right there. The products are not constant, right? That's what shows in blue, okay? So right here, products not constant. In red, the ratios are also not constant. So what that tells me is that we're not dealing with neither direct or what is it? We're not dealing with direct or inverse variation right here. Okay? So what are we dealing with? Well, I go from 2 to 4, 4 to 16, 3 to 6 to 36, 8 to 64, and 10 to 1000. They wanted us to somehow figure out that this happens to be an exponential function. Okay, so this one right here is neither. What is it? Think about this. Y is equal to x squared, right? Something along those lines ends up being our answer, right? That's what the equation actually is. The real answer is neither, but I can see by the numbers, we end up with exponential function. All right, let's go ahead and take a look next up at number 11. So I'm going to repeat the process and what I did in 10. I want to go ahead and take x and multiply it by y. So we got ourselves 1 times 5 is equal to 5. Right here, 5 times 1 is equal to 5. 8 times 0.625, that happens to equal, right here, let's see, that equals 5 as well. I'd continue on, 20 times 0.25, that equals 5. And when I multiply this right here, 50 times 0.1, guess what? That equals 5 as well. So what I can see right here is that when I multiply the two, and remember, I put right there, if the products are constant, which they are, right, and this is from our notes earlier on, if the products are constant, then we have ourselves inverse variation. So products are constant. And that's the reason why. Each and every time we multiplied, we got the same value. Let's go take a look next up at number 12. I have a feeling right here that we end up with direct variation. And let's just cut to the chase. I'll show you an example of this in y. Remember, with direct variation, we're going to take y over x. All right? Remember, direct variation. And in case you're wondering, let's actually go back right here. I put all this information in blue. So in case you're wondering, well, where am I getting all this stuff right here? I went over it in blue. Okay? So you can come back to this, or you could make sure you add it to your notes if you didn't add it the first time. Ratios are constant. So let's go right here on 12, and let's take y, which is 0.5, divided by 2. What do we end up with? 0.25. Next part, I got 1.25 divided by 5. That ends up becoming 0.25. All right, let's take right here, 2.1 divided by 8.4. 0.25. All right, so we do have right here, hopefully now you will see that we've got ourselves this direct variation. And then the reason being, the ratios are constant. Now, normally, I would check all of them because you never know. The book and problems can be a little tricky where maybe that very last one, that 5, or if you take 3.75 and divide by 15, it may not equal 0.25. Is it known to happen? Yes, it is. So I would go through them, check them all. But to save you guys some time right here, I think you understand, or I want to hope you understand, how you can figure out if this is direct or inverse variation. All right, so obviously if I take 3 over 12, that equals 0.25, and 3.75 divided by 15, that is also 0.25. All right, so we now have that all taken care of. Next up, let's go to problem number 13. So they give us values, okay, x and y, and they're saying they're supposed to inverse or vary inversely. All right, so use the given values to write an equation relating to x and y. So remember, our equation that we have is y is equal to a over x. So to start off with, we just need to figure out, well, what happens to be a? Quite simply, we plug things in. Y is 2. I'll plug in x, 2 for x right here, and then get a by itself. Multiply both sides by 2, and a is equal to 4. So when we come up with my equation, y is equal to 4 over x. And that right there is my inverse variation. All right, using the equation. The last thing they do ask is find y when x is equal to 5, and then y is equal to 4 over 5. We can go ahead and leave that as that right there, and that looks pretty good to me. Okay, so that's what y ends up being, 4 over 5, or 0.8. All right, let's see. What else can we do? Let's take a look at number 15. We got fraction right there. Just to make life a little hard for you, make sure you guys are staying up on your math. So we got ourselves y is equal to a over 20. Now it looks like, hey, maybe I could cross multiply, but if I want to get a by itself, I could go ahead and multiply both sides by 20 right here. And this problem is a whole lot easier than expected, or easier than you think, just because there's a fraction. The 20's cancel on both sides, and guess what? A is equal to 7. No sweat, right? So let's go ahead. We come up with our equation. Y is equal to 7 over x. The last part is what happens when X is equal to 5, Y is equal to 7/5. All right. And there you have it right there. I want to go ahead and try 17 and 18. And I guarantee you, these are problems that you're going to want to make sure you know. Okay? You're going to want to know them. So right here says when temperature is held constant, the volume V of gas is inversely proportional to the pressure P of the gas in its container. All right? Pressure of 32 pounds per square inch results in a volume of 20 cubic feet. What is the pressure if the volume becomes 10 cubic feet? To start off with, we need to figure out, well, how do we come up with my equation? Remember, typically it's y is equal to a over x. Okay, if something is being inversely proportional. So now, remember, a always represents what? Think about it. It represents the constant. So if we start putting things together in our equation, hopefully we realize that instead of where a is, I want to go ahead and put t there because that is the constant. So now the big question is, where does V go and where does P go? It says that gas is inversely proportional to the pressure. Okay? Because of that, I will go ahead and put P underneath the A or T, and so we now have V ends up being our value for Y. And then we can go ahead and solve this out right here. Okay? They gave, let's see what we could plug in. They gave us right here 32 pounds per square inch in volume, okay? In volume of 20 feet, cubic feet. When they tell me like pounds per square inch, pressure, area, stuff like that, hey, that tells me that that right there is pressure, okay? So I can go ahead right here, volume, we plug in for 20. Then right here after that, remember that they give us we don't know what temperature is, but what we do know right here is that pressure is 32. All right. So now we got all the parts together. We go ahead and solve for T and multiply 32 to both sides. And temperature ends up being 640. Okay. So now we know what the temperature is. That's the constant. So it says, what is the pressure if the volume becomes 10 cubic feet? Now, so right here, we're going to go ahead and plug our numbers in. I know what temperature is, which is constant, so that's 640, right? That's over up on top. And then so right here, what is the pressure? Pressure is P, but if volume is 10 cubic feet, I need to put 10 in for Y. And then so from here, I can go ahead and solve for P. All right, so after I found T, I now plug that into my equation, and then I can go ahead and solve for P here. Multiply both sides by P. I've got 10P is equal to 640P. Divide both sides by 10, and I end up with now 640. And there you go. The pressure ends up being 64. Okay? All right, 64 pounds per square inch would be the official answer right there. All right, let's take a look and try number 18 for the last one. So the time, T days, that it takes to harvest the field varies inversely with number N of farm workers. A farmer can harvest his crop in 20 days with 7 farm workers. how long will it take for him to harvest the crop if he hires 10 farm workers? So you're hoping that everyone pulls their weight evenly. And, that's always the hard part with finding good work. But hopefully that will be the constant, right? So let's see how we can plug things together. What's not going to change? The number of farmers, I think that's going to change. The time, that's probably going to change. How about the crop, right? No matter what, you're still going to have crop. Whether you have 20 workers, 7 workers, 100 workers, you still have the same amount of crop coming out. So that right there tells me that the crop is going to be constant. What is it inverse with? Inverse varies inversely with the number of farm workers. So I'll put n down below. And so what do we have right here for y? That's going to be t. All right, so c is crop, n is number of farm workers, t is time. So let's go ahead and let's see if we can figure out what the crop is, how much. What do we have right here? We have 7 farm workers, so that'll end up being right here. Number would be 7. We have the harvest and the crop is, we have 20 days, that's the time. And so we got to figure out what that crop is, and that's C. Multiply both sides by 7, and crop ends up being 140. Okay? So it's got 140, I don't know, acres or whatever the case number, something about his crop. Okay, 140. So now let's go ahead and put it all together. We've got T is equal to 140 over, whoops, not going to be 7. We're going to put N right there. And so the last part is how long will it take for it to harvest the crop if he hires 10 farm workers? So time, that's the unknown. We take 140 divided by 10 right here. And we end up with T is equal to 14. And it looks like time is in days, so we got 14 days for our answer. All right, and there you go. We have now finished 7.1, inverse variation. If you have any questions, always come to tutorial or shoot me an email. All right, have a good one.